Alright, last video. This is example 9. And so on this problem we want to solve for x once again. Alright, we have our rules for condensing. So we're going to go ahead and do that. Log base 10 of 5x. X minus 1. We can condense it into a single log. We're going to get rid of log base 10, because remember there's a little 10 here, by raising everything with a base of 10. Cancel it out. We'll get 5. I'm going to go ahead and distribute. 5x squared minus 5x. And what's 10 squared? Should be 100. Alright, and it's a quadratic, so let's move the 100 to the other side and solve for x. Minus 100 equals 0. Pull out the 5. X squared minus x minus 20. 5 times 20 is 100. And then we'll have 5, x minus 5, and x plus 4. And so our two solutions are x equals 5 or negative 4. Except for you need to plug in and check to make sure this works. We'll go all the way back to the very beginning and 5. So the key on this is that you have to do logarithms of positive numbers. No zeros, no negatives. So when we plug in 5 right here for x, that's a positive. And then 5 minus 1 is still positive. No problem. We like 5. But what happens if we plug in negative 4 right here? That's the logarithm of negative 20. 5 times negative 4. You cannot do the logarithm of a negative. Therefore, negative 4 cannot be one of your solutions. All right, go ahead and see if you can do it yourself on problem 109. First step, condense them together. Log 4 of x over x minus 1 equals a half. Raise everything to the 4. X over x minus 1 equals 2. The square root. But it's plus or minus 2, so keep that in mind. We'll have two answers here. So we're going to multiply this by the x minus 1. So x equals 2 x minus 1, or x equals negative 2 x minus 1. Need both solutions. And so let's go ahead and solve all these out. X equals 2x minus 2. So x equals 2. One possible answer. And x equals negative 2x plus 2. So 3x equals 2. X equals 2/3. And on 109, we're going to plug both of these back in and make sure that we don't have any extraneous solutions on this one. So we plug in the 2. All right. Let's look down up here. 2, positive. 2 minus 1, still no problem. What about if we plugged in 2/3 on the bottom, though? 2/3 minus 1 is a negative number. Get it out of here. We can't have logs of negatives. So 109 we cannot do. Last example. All right, this is continuous compounding, so we're going to use our a equals PERT, P-E to the RT. We put in $500 at a rate of 6.75%, and we want to know how long it's going to take us to double our money. So we're going to double our money and end up with $1,000. So let's solve for t. Divide both sides by 500. We'll get 2 e to the 0.0675t. Let's get rid of that e. Natural log. Natural log. The natural log of 2 equals 0.0675 t. Divide both sides and plug it into your calculator. If you do that correctly, you end up with a correct solution of 10.27 years to double your money. Last one for you to try. All right, on this one, the instructions say $2,500 is our starting amount, invested at a rate of R, and in problem 117, R is 5%, compounded continuously. Find the time required to double and triple. So just like the last problem, and on this one we started with $2,500, so to double, you'll end up with $5,000 equals 2,500 e to the 0.05 t. So 2 equals e to the 0.05 t. We'll get rid of the e with the natural log and plug that in to divide by 0.05. And on 117, t is going to double. The time necessary to double is going to be about 13.86 years. All right, and so the same thing, I'm going to jump straight to this step. I want to triple my money. Here I'm doubling my money. If I'm tripling my money, it's going to be a 3. E to the 0.05 t. And so we'll have natural log of 3 equals 0.05 t. And so plug in natural log of 3 and divide by 0.05 and t. How long will it take us to triple our money? About 22 years, 21.97. So that's everything you need to know for 3-4. Please try those problems again if some of them didn't make sense. Try some of the other problems, and you can also look at the review problems at the end of chapter 3 for extra help.